Patrick, are we good now?
Yes. I'm good. We are now recording.
Okay.
Okay.
All right.
Okay.
Just let me give Joy the rights once more.
Okay. Sawa.
Yep. Joy, you can take it up. Sorry for that, guys. So sorry.
All right, Esther. So guys, can you see my screen? All right. Asanteni. So let's just go ahead. Hi, so what are IP addresses? Gideon. Hata hatujajua IP address ni nini jamani. Pole, we're getting to there, I promise. Tusikimbishe syllabus sana. Hata mimi ninaogopa tuikimbishe. All right. So, what are IP addresses? So, an IP address is yesterday we learned about a MAC address, right? And you were told a MAC address, it uniquely identifies a device, right? But now when we come to IP address, it also uniquely identifies a device, but now on a network, all right? And each device that will be on the internet will be given. If you hear background noises, kindly forgive me. Majirani watoto wamefunga. It is the holiday season na wako nje. So IP addresses, they uniquely identify your device on the network, and each device, kila mtu na device yake, it has its own address. The way you have your own name, it's the same way the devices on the networks are identified. So the moment you hear Abby, you know that we're calling you Abby and we're not calling Gail, all right? So that's how we identify devices. They have their own IP addresses on the networks, and each device on the network serves two main functions. The IP addresses serves two functions. Number one, it's to identify the host, and number two, to also it's also used for location addressing. For example, remember yesterday we were told we have hosts, and the host is the one, it's kind of like giving you service to accessing the network. So you'll notice, like, let's say your IP address is 10.0.0.0. The first two digits, the 10.0, those are your host. But we are going to see that later on. Nakumbuka Patrick alitumia jina jana ya Kasuku. I am so sure Gen Zs do not even know what Kasuku is. So Kasuku, it's some vegetable oil we were using back then in the days when most of you were not around, or when you are, either mlikuwa kwa magoti ama kwa mnyonyi, could be those days. So we had a vegetable oil called Kasuku. Now this Kasuku, we used to take it, and we take two Kasukus, tie a string to them, just like the way you see these boats over here doing. Ai, Musembi, ninakushuku, right? So we tie the Kasukus to Elfas. Wacheni kudanganya miaka, ama mnaficha miaka kwa magoti eh? So right, so we take the Kasukus, we tie a string on both ends, and we go quite a distance. We talk, and when one person talks, the other person is able to hear. So when this one talks, this boat talks, this boat can actually hear what the boat is saying. And funny enough, this science worked. The other thing, I don't know if you guys remember from science experiments, we had an experiment where you'd take a glass, put it on the wall, and you did eavesdrop on what either the neighbors or the person in the next room is saying. So you're able to hear what's going on the other side of the wall. So this is how the communication started, right? And we learned about DARPA, went to ARPANET, then went to internet. Do you guys remember? And those who love a little bit of mischief, you might have come across why the US government developed DARPA. Well, we are told it's because they wanted to communicate with the university, but what were conspiracy theories? Musevi, ulizaliwa 19 what? Now I am eager to know, right? So what are conspiracy theories? Know what happens with DARPA and why we got the internet. Elfas, kindly stop lying. I don't know if the 197 should be 201, but either way we listen, we do not judge, right? So IP addresses, they work at layer 3 of the OSI model. And yesterday we learned a little bit about the OSI model. This is something that we keep on refreshing every single day. Yeah. So, a very nice question, Justin. Right? So we learned about the OSI model, and we learned that it has layers. And on that layer, that's where we have the network layer. So that's where you're going to find your IP addresses communicating, because they are communicating on the network, all right? Hi. And at this point, we might know that IP addresses can either be static or dynamic. Now, the difference between static or dynamic is static, when you're given an IP address on the network. Let's say, for example, you're given an IP, you set up you launch your instance, and you set up your EC2 instance, it's ready, it's running. You'll be given a public IPv4 address, right? And when you're given your public IPv4 address, next time you're launching your instance and you've been given an IP address, note down its IP address, right? And then stop your instance and run it again after a few seconds. You'll notice that you'll be given a new IP address because it's dynamic. It will change, all right? And dynamic IP addresses, they change once you either stop your instance, you either close your server, and once you start your server again, you'll be given a new IP address. And for static IP addresses, means that once you create your EC2 instance or you create your own personal server, you're given an IP address. But whether you stop your server, rerun it again, anything away from terminating, do not terminate your servers if they are in use. So once you stop, you run again, when you write down your IP address the first time and you stop your server and rerun it again, you'll realize that your IP address did not change. So that's a static IP address. All right. And an IP address can either be public or private. So for public IPv4 address, the one that I was always telling you to copy when you're SSHing or you're going to check on it on the HTTP, that public IPv4 address, or just that public IP address, it gives you access to the internet, all right? Like, for example, when we are copying our public IPv4 addresses to SSH, we could be able to SSH onto them. But if you copied the private IP address, you won't be able to access the server because it can only be accessed inside your own server and not outside, all right? Public IPv4 addresses have access to the internet and can be accessed to the over the internet. Vice versa, a private IP address cannot be accessed over the internet. And in our next class, you're going to understand why. If you look at, say, Safaricom, you go to their site and you say want to access their DB, you won't be able to access their database. Why? Because even if you can access their browser, their website is in the public IP. It has a public IP address. That's why you can access it. It is on the public subnet. But when you go to the database, when you have something that you don't want the internet to see, for example, your database, remember your database contains data for your users, and data contains, say, like names, phone numbers, PCI information for cards, bank, credit card, debit cards, all those information. You don't want people to access your database, so you place your database on a private subnet and it can't be accessed. So it's the same with private IP addresses. They cannot be accessed over the internet. All right. I hope you've understood. If you've understood, give me a thumbs up. Nijue tuko pamoja. All right, Justin. All right, guys. Very nice. Sawa sawa. Tunaweza endelea kwa mwendo huo huo and get to see how our public and IP addresses work over the OSI model. So how about you use the public IP, public subnet, and write IAM policies. So Gideon, IAM near security of your cloud, right? Not of your network. You have to secure your network. If you remember when you were learning well-architected framework, when you were learning about shared responsibilities, we said that you as a customer of AWS, you as a customer of AWS, you are supposed to secure anything that you launch on the cloud. So if you spin up, say, a private network, a VPC, you are the one who is responsible to protect your VPC. Okay. So for example, you have your subnet. Like today, I know you're going to set up your public subnet and your private subnet. When you create your subnets, you have to secure them. All right. You have to secure your subnets by something that we call network access control list. They're called NACLs. Okay. So you use the NACLs, the network access control list, to protect your networks. But if you remember when you were learning about EC2 instances and you wanted to protect our EC2 instances, we used security groups, right? So you see, even the NACLs themselves, when you're protecting your network, you cannot protect your instances. You also need to protect your instances using security groups by allowing SSH, allowing HTTP, allowing HTTPS, that way. NACLs. Wewe msembi uko peke yako. Right? Reggie saying, so KCB internal networks use private IPs. I honestly do not know. I do not know about banks. Sijafanya kazi KCB. Kama uko na connections unaweza niulizia nikaulizie. All right. So let's see how our private and public IP addresses run on the OSI model. So our IP addresses work at the third layer of the OSI model, and we said the third layer is the networks layer. So up until everything about networks now inakujia. And we're going to run these commands on our labs. So the bring, the trace out, the trace out. So you're going to run those on the lab after this class. Then there's this RFC that provides a guidelines on how to provision IP addresses to either be public or private. Okay, and only these IP addresses, the ones that you see here, from 10.0.0.0 to 10.255.255.255 and 172.16.0.0 to 172.31.255.255 and 192.168.0.0 all the way to 192.168.255.255. These are the ranges that we have been provided for on the internet for private IP addresses. Okay, and we're going to learn a bit more about IP addresses later on. So I'm sure right now, if you check your IP address, if you're using your home Wi-Fi, it will be around 192.168. It will be around 192.168.something.something. If you go to AWS, right, Gideon, if you know how to check your IP addresses, type for me there. I think it's what command are we using? ipconfig. For Justin is 192. Let me just check. I cannot remember how to check my IP, but ifconfig. Okay. Try run ifconfig and then tell me your IP address. All right. So when you go to AWS, you're going to see that you're being assigned a private IP address of 10.0.0.something or 10.255, 10.something.something.something. Yes, on the, you can actually tell me IP addresses. I won't hack you. I'm not in security. Tell us your IP addresses. Hatuwezi zi access. Ziko private, I promise. Right? Now, it's important to know about IP addresses because, say, for example, you're here and your Wi-Fi is lagging, your Wi-Fi is low. All right, Gideon, yeah, it should be that. And your Wi-Fi is slow and you want to know why. If you're a networks engineer, you need to be able to troubleshoot, all right? If you're a cloud engineer, you should be able to troubleshoot. If you want to be a solutions architect, you must know how to troubleshoot networks because if you're spinning up servers, Mohammed, tupe uhondo.
Kidogo kisa. Sorry.
All right, msimwage mtama please. Hatupindi mushene, sisi ni watoto wa Mungu. Right? So, you want to be able to troubleshoot and know where is the issue. So instead of calling your provider, your network provider, hello boss, net iko chini, niangalilie. My network is down. What's going on? If you have networking skills, you can be able to actually troubleshoot for yourself, get to know what's going on. At least nowadays we got speed test and Ookla. We can be able to do this over the internet to be able to know our speed of internet per second, but troubleshooting is quite important. Okay. All right, so layer 3, the network layer, it translates the logical network addresses into physical MAC addresses. And the logical MAC addresses are our IP addresses, okay? The network layer determines how to deliver the message, and it determines how to break down the message if it's too large. Remember yesterday we were learning about sending our data, yes, packets, all right? You remember? Not the milk packets or packets, these ones are broken down pieces of data being transmitted over the internet. So so this is what happens at the third layer. So at the network layer, our IP addresses, our logical network addresses are translated to physical MAC addresses, and at the network layer, it determines how to deliver our messages. It determines how to break down the message if it's too large. And there are many protocols that belong to the network layer. For example, we have our TCP, UDP, IP. And we've checked out on the private IP addresses, and we said that according to the RFC 1918, these are the provisions that you've been given to have our private IP addresses. So even when you're going to the internet, for example, in the next class, you'll be setting your own IP addresses. You should be able to know that your private IP addresses should be along these lines, okay? And here it's telling us what you are learning, that with a private IP address of say like 10.0.0, your content cannot be accessed over the internet. It is only accessed through a private network. And a fun fact is that AWS has its own private network, and we are going to learn about that later on. And it is one of the ways that AWS uses to save us cost of sending data. For example, I saw on LinkedIn an organization was using EC2, not EC2, but ECS for their containerized application, and it was accessing data from, I think it was S3. And their usual per hour cost was around $30 as at yesterday, and from the time they started using the ECS. So in the morning, guys wake up, go to work, and when the project manager checks their bill for the day, it's doubled. So instead of $30, today they're being charged $60. Why? Unfortunately, when someone was spinning up the containers, forgot to link the ECS to S3 via the private network of AWS and connected it to the public internet. And one of the costs that we're going to learn is that in AWS, you are charged for data out. I remember Patrick was telling us data in is not charged. So you can transmit as much data to AWS as you want. But the thing is, you'll be charged when you want to access that data, right? So ECS wants to access data from S3 and it's using public internet. So the cost was double. Whereas if they are using the private AWS network, it will be zero. So that's where, so you need to be able to actually understand these things, know about private IPs, public IPs, and you're also going to learn also about when you're provisioning some of these services. For example, like if you're going to be using CloudFormation to or any infrastructure service, or any infrastructure as code like CloudFormation, Terraform, whichever you want, you need to be able to know how to give proper IP addresses to your services, to your servers. That's very, very important, okay? All right. So let's move on ahead. learn about IP addresses. We're going to start with IPv4. So IPv4, if you want to know that an IP address, Gideon, here comes your answer. If you want to know that your IP address is an IPv4, it will have four 8 digits, right? The first 8 bits, the second 8 bits, the third 8 bits, and the fourth 8 bits, all separated with a dot. So for example, you'll be having something like 10.0.0.1. That's an IPv4 address, okay? And 192.168.50.31. That's an IPv4 address. So it contains 4 numbers from number 0 to 255, and they're separated with a period or a dot, okay? And they have a fancy name for it. It's called a dotted code, all right? I hope you've understood about IPv4 addresses. So an IP address is made up of a 32-bit number. So you see, there are 4 parts, okay? Each part contains 8 bits. So in total, 8 times 4, we get a 32-bit number, all right? And it's exactly what we've said. It should be like da-da-da, dot da-da-da, dot da-da-da, dot da-da-da. That's how you know you have an IPv4 address, okay? Now, remember we were saying that they are separated into 2, and we said one is for the host and one is for the network. For example, for IPv4, this will be for the host and this will be for the network, all right? You can get like, if you want to have different devices with different IP addresses and you want to assign each one of them, you're going to say, let's say we're going to take a host like 10.0, okay? So you can have a 10.0. The first one can be .0.1. The second one can be a .0.2, .0.3, right? So that you can be able to identify them, all right? Sorry. So for the network is the first 2, and for the host is the last 2. Sorry for the mix-up. So the network portion of the IP addresses is the number assigned to your network. For example, you're going to have a network. We create a private network on the VPC, and we need to assign our IP addresses to our network. We might have, say, several subnets in there, and each subnet is maybe going to have its instances. So think of a network like a big house, all right? So think of this box as a network, all right? It's one big network, and you might want to subdivide it. Remember, we learned about the word subnet, and some of you are telling us that a subnet is a subdivision of the network. So you might subdivide this into 2. So we can have, like, this one has divided it. We can say like these 2. We can have the top part and the bottom part. We can say the top part should be the public subnet. The second part should be the private subnet. So we are going to have different, and maybe in these subnets, we're also going to maybe have our instances. We can have like 3 instances here. We can have like 4 instances here. And each instance has its own IP address. So you should be able to actually give them their own IP addresses. And the first 2, they're for the network. They're the main part. So it's going to determine what will be the rest, the end part of the IP address. So you're going to give your network an IP address, say for example like a 10 or 172 or 192. For example, for Wi-Fi providers, they use 192, right? 192.168. That's the common one. And then now the rest is shared among you commoners. And me, I will have 192.168.32.40. Another one will have .38.80. So all those, so it will give each host its own last 2 digits, but the network will have its the first 2 digits. All right. I hope you guys have understood about IPv4 addresses. Now we go to IPv6. Okay. Now, if you check on IPv6, you'll realize IPv6 is a combination. For example, you check at this number, it's a combination of alphanumerical. So it has alphabets and it has numericals in it. All right. And we are told that IPv6 is an extension of the IPv4 addresses. Actually, someone realized that IPv4, with the growth of devices and with the growth of the networks and internets, IPv4 zinaweza kuja kuisha. So knowing that IPv4 addresses can be limited, what do? We need to increase the number of addresses. So to do that, they gave us IPv6 addresses to extend the range of IPv4 addresses. Okay. An example of an IP address, IPv6, is like this one. This one, it's long and it has both alphabets and it has numbers. And it so it extends the range of IPv4 addresses by a factor of 1028, and it uses a group of hexadecimals. All right. The IPv4 just uses decimals, but for IPv6 it uses hexadecimals. Hexadecimals is like 16. All right. And it has numbers. And they're separated by 8 colons. So the first one was 4, but then the second one is 8. It's like a double of the other one. It increases security. So you can imagine it's hard for someone to actually come and guess this IPv6 address and try to hack it. Unlike, we know, like for Gideon, we can guess it's 192.168.something.something. We can actually do maybe guesses in no. We try hack and see, maybe try now 92.168. Say I know a range of this. Maybe your apartment, your range is 192.168.0. maybe 1 all the way to .0. maybe 10. I can maybe guess the 10 that are in between and get to Gideon. All right. But now for IPv6, it's more complicated. All right. And it increases security. It handles packets more efficiently, therefore improving its performance. All right. IPv4 provided an estimate of around 4.2 billion addresses versus IPv6, 340 trillion addresses. And this is actually quite interesting because I am in the IoT field with a very good friend of mine who is here. And we also use internet in our devices. So for example, I want to create a device that measures the temperature in our class today, right? So I'm going to get a sensor, a temperature sensor, and I'm going to program it. As I'm programming it, I am going to actually give it, it's going to be accessible on the internet because that's what we call them Internet of Things. I'm going to give it access to the internet so that it can send me the temperature to my server, maybe after intervals of around 20 minutes. So because Justin, tutafika hapo soon tutafika hapo, right? So as you're creating your devices, and we also know there's also an influx of per person per device. So we have IoT devices, we have a per person per device. I know like some of you in this class might be having around 5 devices. So you can have your laptop, you can have your smartphone, you can have your Right. Let me just. Mohammed, kindly mute.
Okay.
Mohammed Bashir, kindly mute yourself. Shida ni hatuelewi Kisomali. Tungekuwa tunaelewa, tungeulizia kama venye tunaulizia Atis leo. Belinda, how is Atis? Eh? Belinda. All right. So some of you could be having say a smartphone. And let me tell you something funny. Yesterday, Patrick, when he was training us, he told us about palm tops. Remember, we had laptops, desktop, and before smartphones came to life, we actually used to call them palm tops. Imagine. Because I remember way back in 2005, way back, we did not know about smartphones. We were calling them palm tops. And now they are here just next to us, zinatumika venye zinataka, being called smartphones. They're actually palm tops, yeah? Right? So some of you have your smartphones, some of you have your laptop with you, your desktop, a few screens, monitors right there, a TV, a smart fridge, for those of us who are gifted. Exactly, Daniel. Ukiwa na, back then, even before the 2000s, we had big phones, very big phones that mtoto hawezi inua, inatoshana na kichwa ya mtoto. But now, funny thing is, wamezaliwa na smartphone zikiwapiga picha. It's very interesting to see how technology grows. We had flip phones. Some of you have never seen flip phones. Those were the it. If you had a flip phone, if you had a Motorola, wait, Nokia ikaleta this sliding phone with the QWERTY keyboard. Those were the people, they were buying them at around 100,000 shillings. Now we are here buying smartphones at 7,000. It's so interesting. All right. So I hope you understand why they had. No, shauri yako. Elfas. These phones are expensive. I don't know. Somebody, for example, like notice how when every new iPhone comes out, it's more expensive than the previous one, or even a Samsung. So it's the same way. So imagine when people were using button phones, what did our teacher call them? Press tones or what? Patrick, what name did you use yesterday? Press tones.
Touch tones. Ukifinya inalia ti. That one.
Touch tones. So imagine you had one that, like, for you to press letter S, you go PQRS to type letter S only on a message. You're there, and then Nokia releases a slide phone with a QWERTY keyboard. It was wild. They were crazy. Exactly, Daniel. You'd finger that phone until the keypad becomes color white, like the screen, and you go and exchange the keypad because who's buying another phone? Back then, I know most of you might not relate. Exactly, and you were playing Snake Sense, yeah. Good times, and we had games by then. So now you see, then there was no need for many. Yes, exactly. There was no need for many IP addresses because devices were limited. By now, when we started having smartphones, we started using creating our own IoT devices. You want to have an IoT device for a smart home, and a smart home itself has many devices by itself. So with this advent of many devices, there was a need to increase, number one, the security of IP addresses. Number two, Felix, when you were to 20, I was surprised that people who did not see the 207 post-election violence will be voting. That's very wild. People, I am very surprised. Mnatupeleka mbio, hatuamini, mnatuzeesha in an instance. Okay, so that's why there was a need for IPv6 addresses, but in our course we will not interact with IPv6. Normally people do not interact with IPv6 unless you're a networks engineer. Okay, let's go ahead and learn a bit of dynamic and static. I had touched on it kidogo earlier on, and we said that static addresses, they do not change whether you start your server, stop your server, start your server, stop your server. A static address will always remain a static address, versus a dynamic address. It will always change. Whenever you stop your server, it will always change. All right. Naona tuko na wazae. It's okay, tuko wengi. Tunaficha miaka kwa magoti. Right? So an example, Patrick told us yesterday that we can look at an office setting, and we can notice that if people if you go to an office, let's say you go to Landley office, you're going to see there's a printer, there's a scanner, there's coffee machine, these devices, all right? And he told us that all of us can connect via network to the printer, and Patrick from his desk can print something on the printer. I from my desk can print something from my printer. Felix, our Gen Z employee, can print something from his computer to the printer, and all of us are going to access it. So there are things that cannot have dynamic IP addresses, things that are shared, right? Other thing is could be there are those who have like I don't know, like something like hard drives. They share like files, right? They share like files on a network. Their IP addresses need to be linked up, and they cannot change, because the moment they change, you won't be able to share files together. Now, I digress kidogo. When I was starting out, the reason actually that made me be interested in IoT, I read somewhere on Reddit that someone was working on the office, and the last day when he was leaving the company, the organization, so he had cleared. But if you have an office computer, you have to leave it, right? So later on, when another person came to take up his position, they actually realized that this ex-employee had programmed the coffee maker from his laptop. He programmed it that in a way he can start the coffee maker to start making coffee, give himself time. So let's say around, he'll know by like in the next 5 minutes, coffee will be ready. So give himself time that by the time he's standing up from his desk to the coffee machine, coffee is ready, just picking up and going. So actually, internet and the network, it really came to help us a lot. And thankfully, we think the internet is very, very helpful. I know most of us have been able to open Facebook accounts, Snapchat, for those who are in Snapchat, TikTok, and you're there dancing what your mama gave you, shaking what your mama gave you. Others are in LinkedIn posting their achievements. This would not have been possible without the internet. Right. Now I can, let me be serious kidogo. I hope you guys are understanding. So I hope you've understood the difference between IPv4 and IPv6, private and public, and static and dynamic. All right. Gideon, I'm seeing you. Tuko mbele na wewe. Mbele kuko sawa. Kwanza next year it's campaigns na I'm sure mtasikia hiyo sana. All right. Let's go to IP addresses on EC2 instances. All right, EC2 instances can have either static and dynamic IP addresses assigned to them. And actually, I don't know you guys, do you remember when you're setting up your EC2 instances, there's somewhere, I'm pretty sure most of you passed it, like it's non-existent, but there's somewhere it tells you to enable assign IP. So that's where you're able to assign when you're launching, the server will come with an IP address. So in EC2 instances, we can have static IP addresses, and we can also have dynamic IP addresses. And we said static IP addresses, whether you stop your instance and start it again, your IP addresses will not change. Versus dynamic, when you stop your instance and run it again, you'll be given two different IP addresses. All right. Now, if for example you want to launch an instance and you want it to have one IP address that never ever changes. So let's say, for example, this is the IP address being used to access a website, all right? And you've given it an IP address, say for example 10.20.21.22. You've given it that address and you do not want it to change. What you can do, you can actually request for an elastic IP address. And this elastic IP address, it will be static, it will not change. So whether you stop, pause, start your server, it will have the same IP address. If you do not enable an elastic address, if you don't want to have an elastic IP address, you're going to be given a dynamic address. And dynamic IP addresses, they are free, so that's why most of the time you use them. But you're going to learn later on that EIPs are actually paid for after, say, if they are being unused. All right. Can I have someone to read for me? One person can read this for me and another person can read this for me. We can have a lady and a gentleman. So a lady can read the IP address summary, a gentleman can read this last part. Kindly unmute.
I'll read.
All right.
IP addresses can be made public or private. A public IP address is an IP address that can be accessed over the internet. A public IP address is similar to a phone number that can be found in a public phone book or on the internet. With a public IP address such as 54.239.28.85, which is Amazon.com, anyone can publicly access this over the internet. A private IP address is assigned to computers within a private network, and they cannot be accessed from the internet. A private IP address is similar to a phone number that is privately listed or personal number that is not made publicly available. With a private IP address such as 10.0.0.0, it can only be accessed within a logically isolated private network. EC2 instances have both private and public IP addresses. Private IP addresses are used to route traffic within the VPC, and public IP addresses, when enabled, can be used to interact with the internet.
Done. Okay. Thank you, Fan. Another person, kindly read for me, a gentleman. Kindly unmute and read this.
Okay, let me read. To public or private IP addresses. Public IP addresses can be accessed over the internet. It's globally unique IP address that is assigned to a computing device that must access the internet. Private IP addresses cannot be accessed from the internet. Examples is that application and database servers in your data center are assigned private IP addresses because you might not want other devices to know about the servers.
All right, thank you so much. Thank you. So I hope you guys have understood about IP addresses. And now you know about your IP addresses, all right? Yes, and let's learn about something interesting. We actually have special purpose IP addresses. So special IP addresses, the default router address is typically the second address. For example, in the range of 10.0.0.0 to 10.255.255.255, the 10.0.0.1 will be the default router address. And you're actually going to realize this when you're setting up your networks, when you're setting up your VPC. You're going to see that there's a place where you're setting up your IP address for your server, all right? Now here we are told that if our range is 10.0.0 to 10.255.255, 10.255.255.255, the very first one will be 10.0.0.1, and this one will be for the router, all right? Now, it's also known as the gateway address, okay? Its IP address, it's the IP address of the network router. And then we have the broadcast address. So the broadcast address is the last on the range. So the 255.255.255, this one, it's called the broadcast address. And it is used to transmit messages to all the devices that are connected now to your network, all right? To your network. If a message is sent to a broadcast address, then all nodes on the network will receive it. Okay, this is very, very interesting. So the very first one, if your range is between 0.0.0.0 to 255.255.255, the 0.0.0.1 will be the main address for your network, for your router, okay? It's called the gateway address, but then the last one, it's the broadcast address. And the broadcast address, it will be broadcasted to everyone. So whichever message you send to people, to this last IP address will be accessible to everyone. So guys, for example, if you look at WhatsApp, and we have a WhatsApp community, okay? And inside the community, we have several groups, right? So those in the groups and communicate in the groups, one group when it's communicating, the other groups cannot know what is being communicated in the other group. But whatever is posted on the community will be accessed by all the groups, all the people in that community will be able to access it. So kindly take it as easy as it is, Evo 2, just that. All right. Now we're going to learn how to convert IP addresses into binary. We know that a machine is only able to understand zeros and ones, right? It's only able to understand the binary system. And this is something very interesting. Let me just give you a break of around 30 minutes so that when you come, we can go through this, ensure that you have a pencil and a paper. We're going to do a bit of mathematics. Okay? So let's take a break. Let's come at around 10:45. Ensure that you have a pen and you have a paper. If you're back, type for me you're back. Very nice, very nice. Type for me on the chat that you're back so that you get those engagement points. Alphas, you're back. Anthony, you're back. Basil, you're back. Juma Omonji, you are back. Gideon, Silas, nimekuona pale. Belinda is back. Purity, Tony. Fan, karibu. Justine and Sandra, you're welcome. Hello Leonard, karibu kwa class leo. Abby, you're back. So, how many of us have their notebooks with them? Ivy has her notebook. Okay, very nice. All right. Hi, Abby. Hi, Mary. Hi, Angela. Hi, Prudence. Prudence, hatujasikia sauti yako. I can tell you for sure. Right, guys. So let me go ahead and share my screen. So I want us to do something a bit fun. But before that, let's just learn about pots so that we can go to mathematics a bit later on. Right, I hope you guys can see my screen. So we're going to finish up with this one. So let's just jump to pots because this is something that you've come across and you've interacted with. Sorry guys, if you hear gunshots, kindly ignore. There are a few, but kindly ignore the gunshots if you hear them. All right, so let's learn about pot numbers. So, okay, for pot numbers, you guys, do you remember when you were setting up your EC2 instances and when we wanted to SSH into your instance, what did we do? On the security group, we enabled port 22, right? Do you guys remember? So the reason why we enable certain ports is so that we can be able to interact with them, send data through them, access our content and information from them. So if we want to SSH into a server, we have to enable port 22, and even not just in AWS, any server. So let's say you have a server hosted on, say, like DigitalOcean. You want to SSH into it. On your machine, you have to enable port 22 so that you can be able to access it. All right. And port 53 is for the DNS. Port 80, I know you did this on your assessment. We did this also on Thursday morning. Was it Thursday or Wednesday morning? Remember when we were creating a server? And then after creating the server, we installed Docker and Apache, remember? And on the Apache server, we had an index.html web page. And for us to be able to access our website of the index.html, what did we do on the security groups? we enabled port 80. So port 80 is for HTTP. Port 443 is for HTTPS, all right? So anytime that you want to, you say, like, for example, you're hosting your e-commerce platform. Remember, we were selling clothes earlier on when we were starting this course. We had an e-commerce site for selling clothes. Remember, we had our online boutique. So we now want to, well, we want to host it on an EC2 instance, and we want people accessing it through HTTP and HTTPS. All right. So for your customers and users to be able to access your site through HTTP and HTTPS, you enable port 80 for HTTP on the security group. You enable port 443 on the security group. Port 443 is for the secure HTTP, so HTTPS, all right? And there's also this for RDP 3389. So this is very, very important. If you architect and or even an account manager in an organization, let me give an example of Royal Mabati. I don't know if it exists, Royal Mabati. So let's say you've been given an account of Royal Mabati and you need to be in charge of their account, and they have servers. So if their users, if the people, if they're not users actually, the employees of Real Mabati are having issues with their server RDP to access their server from Nokia, right? So these are some of the reasons why we enable certain ports, and these are the most commonly ports used. I promise you, unless you're you need to bounce around your network, immediately you'll be using this, and mostly it's for developers. I hope you guys can get me. Thanks. Silence means yes. All right. So you'll use, if you're a developer, if you're a solutions architect, you're going to use port 22 to SSH into the server. And whether there's some things that you cannot do without, there are some things that you cannot do if on the, say, like on the web, on HTTP, HTTPS, you can only do them on the SSH side, right? So if you need if you maybe need to go into your server, change a few configurations on your applications hosted there, you can use SSH, all right? And another commonly one used is HTTP and HTTPS to enable your access to the server over the internet, so people can be able to access your website, can be able to access your application over the internet, either securely or unsecurely. Another one, if you'll be a solutions architect or an account manager or a support, you need access to RDP, all right? So I hope you've understood that. That's something small about ports that we'll be interacting with. Mostly it's SSH, HTTP, HTTPS. And for this course, it will be port 22 for SSH and 80 for HTTP, all right? All right. So guys, let's go to mathematics. I need us to learn about converting IP addresses into binary. All right, we'll just come here and use the final page on page 21. We're going to use this example and a few more. All right. So let me just note this down. This is 219.103.2 21.59. So as I told you earlier, remember that a computer actually understands binary system, okay? Binary is on the base 2. Decimals is base 10, hexadecimal is base 16, all right? And the computer only understands base 2, the binary. So for us to understand how the binary actually works, we have a short exercise we are going to carry out, you guys, until you understand. So we're going to convert port numbers, our IP addresses into binary. So are you ready? I'm just going to stop sharing this screen and share a spreadsheet. So if you have your notebook, kindly get it out. Let's do mathematics. I know some of you who are from my era, we are not so mathematically gifted, but this one is fun. This one, I promise you, is fun. This one is just division and subtraction only. So I'm just going to share a spreadsheet that I have here. Emi tuchekele. Eh? Just laugh in a way that will please the Lord. Asikasirike na wewe. Right, I hope you guys can see my newspaper. I hope hizo gunshots haziwasumbui. All right, so we have an exercise, all right, and we need to convert this number to 19.103.21.59 to binary, right? So we need to convert this. Okay. Now, people, get your books out, get your pens out. Follow me as we do this, because I'm going to give you like just two. You show me. Someone is going to show me on the screen. Okay. Right? Are you ready? If you're ready, let me know. If you're ready, let me know. Are you ready for some mathematics? Gideon, you're ready. Very nice people. Clinton, Felix, Alphas. Very nice. Right? If you have a deep phobia of mathematics, take it from me. It's not hard. It's just division and subtraction to do it. And we're not dividing with 178 or sujui. No. We're just dividing with 2, right? So let's go ahead. I'm going to show you 2 methods using this IP address. And then you guys are going to type for me on the chat, which is your favorite, all right? And I'm going to take one person to do an IP address for me on a division one and another one on subtraction one, all right? So let's start with, I know people have a bias of, we as humans, we have a bias of the very first thing that comes, it's the one that we bond with. For example, the very first open source AI that came, we bonded with it sana. So people prefer ChatGPT to Gemini. Most people prefer Microsoft Windows to Linux. So it's just something humanly configured in us, in our DNA. So I'm going to be biased and I'm going to start with, honestly speaking, my favorite is the division one. Yeah, I think we can just start with the division one and then we go to the subtraction one, all right? So let me just write here, division. Hello, meanwhile, my maths. Imagine, my mathematics teachers should see this. All right. So what we are going to do, we are going to break down this IP address into each, all right? First, we're going to start with 219, all right? So hapa ni wapi? Uko wapi? Tuko klasi ya hesabu leo. Frank. Oh, Frank is with us. Frank, if you're with us, let me know. All right, Frank is with us. So I'm so sorry for using Swahili. You should come down to the east. All right. I'm sure by the end of this course, you'll know a lot of Swahili. There's sawa. There's sawa means cool, poor, good. There's pole, sorry. Yes. So we're going to start with. So we're going to break this down. So this is a normal IP address, what you'd see, for example, like yours, right? So we have 219. Okay. So to be able to get the binary number for this IP address using the division method, we are going to break it down to each, all right? So for division, we start with thank you for translating for Frank Patrick. All right. So we are going to start dividing each of these numbers to 2. Yes, thank you, Frank. Next you'll be half Kenyan soon, I promise. We're already almost 1 month down, right? Now to serious business. So now we need to divide this number divided by 2 all the way to the very last bit of it, okay? Now, so and here's the rule. If the number that you're dividing it with, we're going to break it to divide it by 2 all the way to the last point, and we're going to write our answers right here. And as we write our answers, we're going to write a remainder. So what is important to us is this remainder, all right? So let me just write answer, and let me just write remainder. Or those who are native will say modulus programmers. It's okay, but let me just write a remainder. Remainder. Is there something like this? Kizungu ilikuja na mili. Ama niandike balance. My Lord. Remainder. Acha tu niendelee. It came with a sheep. It came with sheep, with not sheep, but sheep, mainly sheep, the big boat, all right? So now we have 219, all right? So we're going to start all this way so that you can be able to follow down through, all right? And what we're going to do, we're going to do 219, we divide by 2. Somebody shout an answer for me. Kindly, anyone do shout your answer. Somebody and
109.5.
Yes?
109.5.
All right, so we have a remainder. So you see here we had 109.5. Sindio, if we had 109.5, let me just write 109.5. We have a remainder. So if we have a remainder, instead of saying yes or no, we're going to write 0 or 1. All right. So if we have a remainder, remainder. So if you have a remainder, it's going to be 1. If we don't have a remainder, it's going to be 0. All right. Higher. So we have a remainder. All right. Let me just bold this. All right. So now we have a remainder. So what we're going to do, we're not going to take the 0.5 because we've already written it as a remainder. So we're going to just leave it as 109. Okay. 109, we have a remainder. So yes. Then we're going to come here and write the balance of 109, and then we're going to divide it by 2. Remember, we're going to divide until to figure 1. All right. So what is 109 divided by 2? Answers ni si za githeri, but unmute. Just unmute somebody with a calculator. Let me know what's the answer.
54.
Does it have a remainder?
Yes.
All right, so if it has a remainder, you write 1, all right? Come here, write down your 54, all right? So 54 divided by 2, we have 27, right? 27. And 27 times 2 is 54. Do we have a remainder? Do we have a remainder? Anyone? You guys unmute.
No.
We don't have a remainder. So if we don't have a remainder, we write what? We don't. Exactly. 0. Okay. So the next number we are dividing is this 27 divided by 2. We have what? (27) divided by 2. Answer is
13.5.
13.5, right? So we're going to have 13 with a remainder. Okay. All right. Are you guys following? Or is it easier if I write the points so that you understand? All right. I hope. Kindly go with me. I need you guys to understand. All right. Very nice. So I think for the other one, I'm going to write the point so that I don't leave you behind. So next we have a 13. 13 divided by 2, we have what? We have 6 with a remainder, right? So like 6.5. So we have a remainder, okay? Cindy, 6 times 2 is 12. Remainder 1 for the 13. Higher. 6, we divide by 2. What's the answer? People. No, G.
3.
Does it have a remainder?
No.
It doesn't, so we write as 0. Okay. Hii 6 mbona imejifanya mkuu hivi? So next we have 3. 3 divided by 2.
1.
1. Does it have a remainder?
Yes.
So it has a remainder. All right. Then we have 1. All right. So now with 1 divided by 2. We have
0.
We have a, yes, so a 0 with a remainder, okay? Sindio? And we are at 0, so we cannot go ahead. Sindio? So now what we do, so now what we will do, we'll come and write this number, all right? And we're going to start from the top to the bottom, all right? So our answer for the 219, it's going to be 1 1 0 1 1 0 1 1 to the base 2. Have you guys understood? How was that? It was easy, Cindy. So now,
Yeah.
all right, very nice. So let me just block this. Let me block this part. So that you okay, or let me just use one big one for the outer one. It's okay. So where was this one? Okay. So now let's go to, what's the other number?
103.
Okay, 103. So you guys are going to guide me through so that we do this faster. So remainder and our answer, okay? So, all right. So now we have 103. 103 divided by 2. Mm-hmm. 103 divided by 2. Somebody help me.
51.5. 51.5.
Okay, 51.5. Let me just write with the points and then you're going to let me know which one works. So it has a remainder. We take the 51, we divide by 2, we have
25.
Hmm?
25.5.
25.5. So we have a remainder. We take 25, we divide by 2. What's the answer?
12.5.
12.5. So we have a remainder. What is 12 divided by 2?
6.
6. 6 without a remainder. Sindio?
Yes. Yes.
Frank, Sindio means yes. Yes with a question mark. Yes.
0.
All right. Yes, we write 0. All right. We go to 6. 6 divided by 2.
6.
We have 3 without a
3.
remainder, right? Yes. All right. For
0.
the next, okay. 3 divided by 2, we have 3 divided by 2.
1.5.
1.5. So we have a remainder. All right. So we have 1. 1 divided by 2.
0.725.
All right. So we have a remainder. All right. So someone read for me the answer.
Yeah.
Top to bottom. See bottom up. Top to bottom. Top to bottom. 1, 1, 1. 0, 0, 1, 1. All right.
0, 0.
Mm-hmm.
1, 1.
All right. Yeah, just a second. Actually, we read this bottoms up for Roto. We read this bottoms up. So from 0 all the way to up, all right? So here our answer will be 11, 1, 1, 0, 0, 1, 1, 1 to base 2, all right? We're reading from down to up, bottom up, all right? From 0, the very last answer, all the way to up. And then we write our answer. But then remember, you remember that when you were reading on the notes, we were told that IP addresses are 8 bits, 8 quad bits, something of the sort. So each is like 8888. You remember? Do you guys remember? And we said that the total comes to 32. So you have to ensure that for each of your answer, the number that you're getting here actually sums up to 8 numbers. So for example, like here we have 1, 2, 3, 4, 5, 6, 7. But then they should be 8. So if yours are less than 8, what you do on your answer, you come to the very first number, the last one being ilimalizia, the one that had a 0 point. You come and what you do, you write the missing number of zeros. For example, if you had say for example our number was ending at 111, what we could have had is, you see these are just 3, what we could have added is 5 zeros for it to be 8. 8 bits, okay? So, and my Excel does not accept a 0, but we're going to leave it at that, okay? So it has to be 0. Let me just see if I can have a 0. Yes, let me just leave it as that. Ignore the first 0. Let me see. If you're good in Excel, tell me how I can have my numbers accepting 0. What do I do? I use that. All right. Interesting. Let me
Joy,
try. Yes.
I have a question. So
Okay.
all of our answers, we'll be reading them from bottom to top.
Yes. Bottoms up. Yes, Amy.
Okay.
All
Okay.
right. All right.
Even the first one.
Yes, even the first one.
Hiyo zero umetoa wapi?
Hii 0 nimesema unakumbuka tukisoma about IP addresses. So for example, like the one we have here, sini 219.103.21.59. Pale kwa notes tumeambiwa for an IPv4 address, number 1, they have to be they have to be divided into 4. I forgot a dot here. All right, they have to be divided into 4 digits, all right? And each digit, it should be 8 bits. So the total should be 32 bits, all right? Na nikakuja nikasema, unaona sasa kama hii, the first one, it had 8 bits, it had 8 numbers. So think of it as, when I say 8 bits, just think of it as 8 numbers, okay? So like this one, it had 1, 2, 3, 4, 5, 6, 7, 8. It has 8 numbers, okay? But now when you come to the answer here, our second answer, it has 1, 2, 3, 4, 5, 6, 7. It has 7 numbers. But because we need it to be 8 bits per 8 bits, each of these has to be 8. So the 219 has to be bits, the 8 bits, 103 has to be 8 bits, 21 has to be 8 bits, and 59 has to be 8 bits. But because now for 103 tunakuja kupata the whole answer na tunapata ikiwa just ni 7 numbers. All right, what we do for it to be an 8-bit, we add a 0 at the beginning of the number venye tutaandika, okay, ndio ziweze kufika 8. Kama sasa hivi venye nime add, you'll see there'll be 1, 2, 3, 4, 5, 6, 7, 8. That's why they are 8. And Habakkuk, thank you for the tip. All right, Felix. Anyone else who's not understood, kindly unmute. In fact, this mathematical time, kindly just unmute, ask, talk. Just talk to me. Let it be engaging. So let's try the other one with together. So the first one is 219.103.21. So let's go to 21. And now this one you're going to guide me kabisa so that I see if you've understood. So we're going to have 21. We're going to have our answers, and then we're going to have the remainder. Okay. So for 21, and then you're going to see here now about the 8 bits, the way I'll tell you. All right, so 21 divided by 2, it will be
10.5.
10.5. So we have a reminder. All right, and about 10 divided by 2? 5 without a remainder, so we get a 0. And 5 divided by 2?
2.5.
2.5. So we have a remainder All right, and 2 divided by 2, we have 1.
One.
So we have a remainder, sindio? And then we have 1 divided by 2, we have
0.5.
0.5. So we have a remainder. Okay. So now we read our answer as bottom up. Okay. So we're going to have 1, 0, 1, 0, 1. Okay. And then, sorry, how many numbers are these? 1, 2, 3, 4, 5. So how many numbers do we need for them to be 8? How many zeros do I add?
3.
3. So 1, 2, 3. All right. And Habakkuk has given me a tip of adding an apostrophe, and that's your answer. So it's going to be 0, 0, 0, 1, 0, 1, 0, 1 to base 2. All right. So now it's easy. And there you're done with the third one. So let's go to the final one. And the final one is 59. 59. Okay. We get our answer. And we get our remainder. Okay. So let's start 59 divided by 2. Answer.
29.5.
29.5. So we have a remainder. We write our remainder 1 and we take 29. So 29 divided by 2. What's the answer?
14.5.
14.5.
14.5.
All right. So we have a remainder. And then 14 divided by, 14 divided by 2, we have 7 without a remainder. Sindio? Right.
Yes.
So 7 divided by 2, we have
3.5.
3.5, right? So we have a remainder.
Leave in divide.
Hey, Daniel, 3 divided by 2 is what? 1.5. Yes. So we have a remainder. And then we have now the 1, we divide it by 2, we have 0.5. Yes, so we have a remainder, right? So how many numbers are these? 1, 2, 3, 4, 5, 6. Okay, so how many zeros do I start with?
2.
2. And then read for me the answer.
1, 1, 1. 0, 1, 1.
All right, so that's the answer in base 2. So now our final answer is we're going to have this. So our final answer now, let me just put that these ones so that we can separate. All right, so now we can read our entire answers. All right, so 219 is, somebody read for me. Read for me this one. We start with 219.
1, 1.
1, 1.
0, 1, 1.
0, 1, 1. 0, 1, 1. Dot. Somebody read for me this one. Somebody read for me 4. So we're going to have 0, 1, 1, 0, 0, 1, 1, 1. Sindio? Dot. Let me just expand my screen this side. And then we're going to have this one. So we're going to have dot 0, 0, 0, 1, 0, 1, 0, 1 dot. Then we're going to write the last one, this one. We're going to have 0, 0, sorry. We're going to have 0, 0, 1, 1, 1, 0, 1, 1 to base 2. So that's our IP address in binary. That's our answer. All right, so you can see. Hi Roy, kindly get your video off. Karibu kwa class. So this is the way we convert the IP address into a binary. So the machine will not understand 219.103.21.59. The machine will understand 110.110.110.0110 all the way to here. That's the way the machine understands. And you'll understand later when you're learning about DNS, you'll come to understand that the function of a DNS is to convert our IP addresses into something that the machine can understand, which is binary. So happy to inform you that now you can be a DNS by yourself, right? So this is a very fast, interesting, right? So this is a very fast method that we use to convert. This is called the division method. Have you understood, people? If you've not understood, kindly ask me a question before I go to the subtraction one. Gail has understood. Mosembi has understood. Fan has understood, people. Very nice, very nice, very nice. Right? Very nice. So now, let's go to the second method. Thank you, Napoth. So now let's go to the second method. Let's call this the subtraction method, right? Let me just hide all this balderdash and we can start on cell 41A. So let's try the subtraction method, okay? So let's use IP address, or we just use the one that we had, Cindy. Let's use the one we had. We had 219.103.21.59, right? Now, this other method is quite interesting because we're going to create a table, all right? We're going to create a table of 8 bits. Now, somebody tell me all right. So let me see. Let's start from 1, 2, 3, 4, 5, 6, 7, 8. Let me just reduce the column length for this one so we can be able to see clearly. 2, 3, 4, 5, 6, 7, maybe 8. Okay, so for the subtraction method, you're going to write a table, all right? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now what we're going to do, we're going to write the multiples of 2. Okay. So for example, we're going to start with 1. So what is 1 times 1? 1 times 1 is 1. 1 times 2 is, shout your answer. 1 times 2 is
2.
2 times 2 is
4.
4. 4 times 2 is
8.
8.
8. 8 times 2 is
16.
16. 16 times 2 is
32.
32. 32 times 2 is
64.
64. 64 times 2 is
128.
128. Very nice. Okay. And then we're going to write our number right here. Let me just write it here. Okay. Let me just Control X and bring this here. And then you can just go up. Okay. But then instead of writing the entire one, we're going now to divide it into the bits. So I'm going to have 219 in the first one, 103 in the second one, 21 in the third one, and 59 in the fourth one. So here I'm just going to have the 219. Okay. So now this is the subtraction method. Let me just have this bordered. Okay, very nice. We have a little table over there. Okay. Now, what's going to happen is we are going to start our subtraction method, right? Justin, nani analia nyumbani jamani? All right. So now, about subtraction, you remember in the division, we said if you've done your division and you got your answer, and say you got your answer and the number of binary digits you had were around 5, we needed to add 3 zeros on the beginning of the digital number of the binary number, so that we can have so that you can have an 8-bit number. Okay, but now for this one we really don't have to guess. You know why? Because we have the 8 bits here. You can see these are 1, 2, 3, 4, 5, 6, 7, 8. See, these are 8 bits, so those are 8 digits. Okay, now what we're going to do, we are going to subtract each of these numbers. Subtract here now, right? And right here we're going to have our answer. So let me just slide this to the left. Najua kuna watu wakumbuki, we had a dance style called Slido, but I know most of you might not relate, but we had a dance move called Slido. So let's slide. All right. Yeah, Patrick, good old days. So what you're going to do, we're going to subtract each of these numbers. Rich. Nimeona wazai kwa hii nyumba. Okay. So now we are going to now subtract each number. And the rule of the game is, if you cannot subtract, you add a 0. All right? If you can subtract, you put a 1. Ndio sisi na kusema tumechill. Ndio sisi na kuita 5 bob kubole. We are here, we are alive. Shida ni magoti zinalia kakakaka tukiinama. Okay. Now, on the serious note, you know, guys, I'm really trying to be serious here to solve me. Okay? So, let's now subtract. We're going to subtract all these numbers to all these numbers. English. All right. You know, people will be there, think the weather in Nairobi is training us for the weather in Canada. Serious. It's very serious. Okay, so now can we subtract 219 to 121? What is 128, sorry. What is 219 minus, what is 219? Let me just write here. What is 219 minus 128? We get
91.
91, all right? So if we can subtract, we say 1. We say yes. Yes, kidole sambusa. We say 1. So we have 91. Can we subtract 91? Can we subtract 64 from 91? 91 minus 64. Is it possible? Unmute people.
27.
Yes, so we can subtract. So we get 27 in here. If we can subtract, we say yes. Okay. Can we subtract 27 to 32? 27 minus 32 will give us a negative. So we say no. Okay. Now, because we cannot subtract 32, 27 minus 32, we go to 16. So here we write 27 minus 16 and we get 11. Sindio? So because we can subtract, we say yes, we can subtract. Can we subtract 11 minus 8? Yes, we can. So 11 minus 8, we get 3. So here, because we can subtract, we say yes. Now, can we subtract 3 minus 4? No, we're going to get a negative. There are no negatives in the computing world. These are positive side of life. All right, so we say no. Then we go to 3 minus 2. Is it possible? Yes, it is. We're going to get 1. So because it is possible, we say yes, okay? And then we're going to have 1 minus 1. We're going to get a 0. And because we can subtract 1 from 1, we're going to say, yes, we can subtract. We're not getting a negative, all right? We are finished with the first number. Let's go to 103, okay? Now, for 103, can we subtract 128? No. Sindio? So because we cannot subtract, we do not want negatives. So because we cannot subtract 103 minus 28, we write 0. But then we can subtract 103 minus 64 and we're going to get what?
39.
39. So yes, here we can subtract. So we say, yes, we can subtract. All right. Can 39 subtract 32? Yes. And we're going to have 7. Sindio? So because we can subtract, we say yes. Okay. But then 7, our 7 here cannot subtract 16. And it cannot subtract 8. We're going to get negatives, all right? So we write zeros over there, all right? So then we're going to write 7, and then we're going to subtract 7 minus 4. It's possible. We're going to get 3. Sindio? So because we can subtract, we say yes, all right? Now, this 3, can we subtract 2? Yes, we're going to get 1. So because we can subtract it, say yes, all right? And we have 1 minus 1, it's subtractable to 0. We are not getting a negative. So we say we have 1, all right? And that's how you get your answer, okay? Now, let's go to 21. Somebody help me. Can we subtract 21 to 128? Yes or no?
No.
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 All right. And 64?
No.
And 32?
No.
And 16?
Yeah.
Yes. All right. So we do 21 minus 16 and we get what? we get 5, right? Okay. So we have a 5 here. But can we subtract 5? 8 minus 5 minus 8? No. So, but we can subtract 4, right? So it's going to be 5 minus 4. We're going to get a remainder of 1. So because we can subtract, we say what? We say yes. If we can subtract, we say yes. All right. 1 minus 2, we get a negative, but 1 minus 1, we get a 0, which is a positive, right? Okay. So now here we have our answer ready. All right. Hi, let's go to the other number, which is a 59. All right. So 59. So with 59, can we subtract here? No. Can we subtract 64 from 59? No. But we can subtract 59 minus 32, right? Sindio? What do we get?
27.
27. Yes. So because we can be able to subtract, we say yes. All right. And can we subtract 27 minus 16? Yes. Sindio? So we're going to do 27 minus 16. We can subtract, we get what? We get 11. It's possible, all right? And can we subtract 11 minus 8? Yes, it's possible. If it's possible, you say yes, it's very possible. But then we cannot subtract 3 from 4. So if we cannot subtract, we say what? We say 0, all right? All right, and we go to 3. 3 minus 2, it's possible. So 3 minus 2, 3 minus 2, we get 1. So yes, we can be able to subtract, and it is also possible to subtract 1 minus 1, we get a 0, so it's a positive. All right, and there, my people, is how you get your answer, right? So what you just do, you just copy paste all these numbers, all right? So we're going to write, so 219 is 1 1 0 1 1 0 1 1, and then dots, or let me just write here, we have 0 1 1 0 0 1 1 1, and then for 21 it's 0 0 0 1 0 1 0 1, and finally we have 0 0 1 1 1 0 1 1, and there we have our answer. So all we have to do, oh my gosh, I forgot to write my zeros. It's okay. So what you're going to do, let me just add, let me do what Habakkuk told me. I think it's Habakkuk told me I just write an apostrophe, and then I can write 0 0. Here I'll just write my apostrophe and say it's 0 0 0, right? Here I'm going to have an apostrophe and say 0. Okay, right, now I'm just going to combine my answer, and I'm going to have 1 1 0 1 1 0 1 1 dot 0 1 1 0 0 1 1 1 dot 0 0 0 1 0 1 0 1 dot 0 0 1 1 1 0 1 1. That's your IP address. So guys, those are the 2 methods I've taught you. Tell me, which one is easier?
Division.
Why division? Really? You prefer division? Hesabu sio mdomo chako? Musembi, between division and subtraction, which one do you prefer? The division. Let me see what you people are saying. Division. Justin, a script. Ha! No, here it's mathematics. Patrick prefers division. Musembi division. Elfas division. Justin, you think subtraction is different than division? Really? No. Brand division. Ladies, which one do you prefer? Gail division. Really? Chelsea division. Gideon division. Abby division. Amy subtraction. Huh? Really, Daniel? Tony division. You people, you remember I told you, is a human psychology. We all are factored to believe on the very first thing we see. And I told you, I'm just going to start you with division. And you see, because I started you with division, you went for division. You think that is easier. But actually, for newbies, subtraction is way better because you have your answers right here. You get? You're not guessing anything, but yes, I also prefer division. Mi niliwaambia from the start, I'm going to be biased. I'm going to introduce you to division because I also go with that. Right? Okay. You could start. I could have started with subtraction one. Yes, I could have. I think for the next cohort, I'll start with the subtraction one. So that I see. But actually, we have an affinity as human beings to go for the very first thing that we get that is new to us. So now, people, I want you to do this for me. All right? I want you guys to do this for me. 10.255.255.255. And no cheating, hakuna kutumia kazi, no using Copilot or GPT. Use either division or subtraction. You do this for me and then you give me an answer. Let me give you until 2 minutes is enough. Okay, let's do until 11:53. Tell me your answer. Guys, do these two. I need an answer for this one and an answer for this one, and then we can break for lunch. Very nice. I am seeing your answers streaming in. Yes, and you people are getting it. Very nice. You people, smart people. Sure. Sure. Mark yako ya kwanza, mark your very first one. The number 10 one is wrong. It should be 10 10, not just 10. Kindly look into that. 101, yes. 1000, yes. Yes, that's very nice. You people, you got it. Very nice. Perfect. Perfect. Very nice. You people, you've made me happy. Eh? Now I'm going to enjoy my lunch. Imagine today I'm going to eat lunch because you people have gotten it. Very nice. Thank you guys for your answers. Thank you, Prudence. Thank you, Gail. Let's wait for your second one, Gail. Na sijaona answer ya Mwalimu Patrick. Ama alishaenda lunch. Thank you guys for your answers. Bado na subtract. Mwalimu alisema yeye ni wa division. Help us, I see you. Gail, your second one is here. But check on it. So you have 1010. Check on your second one. Gail, check on your second one. It should be like the one for Felix. Yes. So thank you guys for your concentration. Thank you for working with me today perfectly. I appreciate. And let me know, how was the class? Did you enjoy some mathematics in the middle of computing? Exactly, fun. Inasaidia sana. It's really good because subtraction you get to see, especially if the numbers are smaller, you won't get mixed up on the zeros and you can visualize your answer. For division, yeah, division, if you're good at being organized, you won't get mixed up. The math was like an icebreaker. Okay, thank you, Felix. Can I get this recording tomorrow? You're actually going to get it today, Mark. We got you. We got you. All right. Is there an instance where the math goes past 8 digits? So, Justin, in computing, I can't remember whether it was in digital logics, we had several types of numbers. So we are saying of binary, we had the decimal. Binary is this one that you're doing 00110101, that one for zeros and ones. Then we have the digital ones. So it's what we have, like the 10, 20, 30, 1, 5, that. And then we have the octal, we have the hexadecimal. Hexadecimal goes up to 16. We have another one, I think, was going up to 27. I can't remember, but yes.
Joy.
Yes.
I was asking in the unaona kama hii hesabu tunafanya wewe you're subtracting or dividing, yeah?
Mhm.
Is there an instance unaweza divide ipite hizi 8 digits like sasa tuseme umeshapata hizi 0 na 1 8 already but then bado kuna number yenye unafaa divide.
Hapana. No. For IP address, remember there are 8 bits and then there are 4 points, all right? So total lazima ziwe 8. Haziwezi pita. They can't go past 8. Right. So guys, it's 12 o'clock. I don't love eating into your lunch. So guys, I wish you a very good afternoon. Let's get ready to launch instances, create our own networks, secure them, understand the difference between NACLs, Network Access Control List, and security groups, because I assure you that's a question that you're going to get, most likely a few of them, right? So get ready for the afternoon class. Kindly don't miss it. It's going to be fun, interactive, and also, guys, kindly ensure that you do your labs. Today, this morning, we already have 2, right? So kindly ensure that you do your labs. I am going to check because today is on Friday. The very last day we're going to do networking, I think it will be on Tuesday. If by on Tuesday you've not finished networking, you'll have more labs, and Mimi, we do not want to answer a question. Very nice, happy. Yes, exactly. So kindly ensure before you see today, at least it's on a Friday, you have Saturday and Sunday, ensure you get at par with your labs. Okay, remember there are people who got dropped off because of their labs and cases. We do not want that scenario. And guys, for you to get a voucher for your exams, yes, in the cases too, for you to get your vouchers for the exams, AWS is looking at your cases, AWS is looking at your labs, AWS is looking at your attendance, AWS is looking at your contribution, right? For you to be able to get a voucher. So guys, weekend, ensure watu wangu, we said Friday and your deadline. Ensure that all your labs and cases are at par as at the end of the day. And those who did not do the quiz, the deadline was yesterday. If you haven't submitted, let me know. But Patrick and I are going to do our best to get your results either end of today or latest. Patrick, what can we do latest?
Let's just say that they'll have them by Monday because it's
Alright,
quite something. And then I have some announcements once you're done.
I'm done actually. Kindly go ahead.
Okay, cool. So I hope you guys have enjoyed the class the same way I've enjoyed it. Thanks Joy for that informative class. Inyi watu mnanyima mwalimu hata makofi. Pikieni mwalimu wenyu makofi. She has taught us some very, very good stuff. That was really, really good. So I will start from attendance. Is Brian Kipkirui with us today? Brian, if you're present, let me know. Mbio teke so that we release guys to go for lunch. Brian is not in. So Chelsea, you've come late for class, eh? Or were you there from the beginning? Chelsea, you've come late for class. I've just seen you right now. I marked the register, Kitambo. So please change on that. Evans Okoth, is Evans Okoth with us? Evans is also missing. So Mohammed Hamoud and Mohammed Hassan. I think I saw Hassan somewhere. Hassan had unmuted at some point. So where is Bashir? So also those two, we need to check. Yeah. So Chelsea, if you are there, that's okay. Maybe I missed you. That's why I'm confirming. Salem, you also came late for class, right? You are not in from the start. Si ndio Salem? Na wewe kujua senye hauko, it's very easy because you're the most engaging. So Salem, you came late, but it's good. It's good that you've made it. So let us see you in the afternoon. And finally, Samuel Gitimu Gitau. Are you around? Samuel Gitimu, are you around? I remember we told you guys that attendance is a must. If you're not attending, you let us know. If you will be late, you let us know. Because these things, we are not just marking them for formality. They are being tracked both by Landly and AWS. You understand? So please let us work on that. And then, good work, Joy. Now, another thing that I also want to make you aware of, we have small groups. I believe also 54 has their small groups. And this instruction is directly going to 53 because I won't get time to talk to you again before Sanane. So this is what I'm saying. Congratulations to all team leads. We already have 5 team leads for the 5 teams. Each of those teams, your first assignment will be to make sure, as a team lead, make sure that you organize how your team is going to do the labs and the cases starting today. So all labs and cases will be handled in those small teams, not in the channel. In case you have a problem with a lab or you are getting a challenge with a KC, you can now call me in as your instructor so that I can now come and help you. So it is very, very important that you do them and do them as fast as possible. Also, team leads instruction to you. You also need to check. You also need to check with your members, and let us be very open. If you are a member of a team and then you are lagging behind in any cases or any labs, let your team lead know and let me know. Okay, team leads, let me know if they need extra support that I can come in, or if you can handle it as a team. Let us help each other. We are going to come up with a way to reward you guys, to acknowledge and reward you guys in your teams. So we are going to look at different parameters. One of them is how you guys are faring in terms of your cases, how you guys are faring in terms of your labs, how you guys are participating in class. So in class, if you participate in class, those points will also accrue to your members, to your team members, to your colleagues in the teams. And then when also we come close to exams, you guys will also be doing those revisions around there. You understand? You'll also be doing those revisions in those small teams, and you'll also doing some of the revisions and some of the things that we'll be doing. You'll also be doing them as a channel, and also you'll also be doing it generally as a class. What you're trying to do is to promote peer-to-peer learning and make sure that you guys are also taking ownership of your own journeys. So I hope that one makes that one makes sense. That one makes sense. So if you are unsure and you're from my channel, you are not sure about your team where you belong, please reach out to me over lunch, and team leads, I'll be reaching out to you shortly. So thank you, everybody. Sitawaeka sana. Tuonaneni saa 8, we start talking about VPCs. Yes. Esther, anything?
Maybe, Patrick, before we leave, you can talk about the recordings.
Yes. Yes, before I talk about recording, someone has called my name.
Yeah. Can you confirm if Jay has placed us into groups? I haven't seen any communication about that.
No, Joy amesema hapo mtamit at the back of the tent for 54. You will meet at the back of the tent, alafu sando awaambia vile wamewapanga.
Okay.
I hope nyinyi si timu mpangwingwi. Hapa tunapangana tu. Yes, that is awesome. Also, are we having a capstone project at the end? We'll discuss that together with Joy. Our idea is not just to get you guys certified or just to give you these lectures. We also want to make sure that you guys have skills enough that you can do things in the cloud. So we will come up with some interesting ways, and we are hoping that maybe by the end of this program, you guys will also have some mini portfolio projects that you can showcase. You can showcase to future and potential employers. By the way, this program I took with Landly really helped me even to get my first job. Now we are looking for impact. So thank you for that question, Rich, and we'll take that under advisement. Yes, very, very finally, Esther has asked me to talk about recordings. So we have changed the mode of recording. So we are recording these things in our devices, and then we will be sharing with you. So the mode of sharing the mode of sharing, how do you call it? The mode of sharing the recordings will still remain the same. There's a very good Excel sheet that Nani came up with. Joy came up with a very good Excel sheet which tracks the recordings that we have. So you will all have access to that Excel sheet, and you can go there at any time and pick whichever recording or class you'd like to maybe rewatch, maybe just to reacquaint yourself, and we'll make that access open to you guys. Maybe up to the end of our the end of our class, and we can also discuss if we'll continue to give you access to it even after. So I hope that one makes sense. So let us meet Sanane. Salem attendance is very, very important. I'll discuss with Joy to see if we can be lenient this time, because you've always been punctual. But next time, if you figure that you'll be late, please communicate. Please communicate. Please communicate. It's very, very important that we communicate. We are not doing it for formality. It is very, very important. I hope that one makes some good sense. Yes. Awesome. So guys,
Patrick.
Yes. Sharon, yes, I saw your hand. Sorry. Yes, Sharon.
I'm asking about the assignments on the on the gradings. There is the assignments, knowledge checks, labs, graduated and scored. On the assignments, is it the assessments that we usually do after every module?
Yes. Those are the assignments. Those are the assignments.
Okay, and the first one we did was not graded, so I'm just asking because it's not recorded, and also we've done the second one, so I'm not sure if.
No worries. Okay, what we normally do, what we're supposed to be doing as instructors by the end of the program, we are going to take the average of all the assignments that you've done. And one thing that we did even for the first assessment, we said, because this is new for these guys, let us just give everybody a pass. Let us just give everybody a pass for the first one. But moving forward, we'll be marking, and then we'll be writing them down. And remember, it is your final score that will determine which class you'll graduate out of, because we normally have 3 classes in every restart. Class 1, the top scorers will be in the gold class. The second class is the silver class, and the last class is the bronze class. So work so hard and make sure that you guys graduate with gold. I remember Joy during her time, she graduated gold, top of her class. I also graduated gold, top of my class. So if you are being taught by guys who are gold graduates, then you ought all to be what? Gold graduates. And we are here to help you. So TBD. Thank you, Sharon, for that question. So we will make sure that we communicate back the results to you after every assessment. So TBD. Awesome. So bye-bye, guys. Go have your lunch. See you at Sanane. And before you go, again, sorry. And moving forward, starting tomorrow, attendance will be taken exactly at 8:45. The room is normally opened at 8:30. So you have 15 minutes to get yourself in class. Tomorrow is Saturday, guys. Thank you, Gideon. From Monday, from Monday, we will be marking attendance from 8:45. You understand? We'll be marking attendance from 8:45. Please, guys, make sure that you attend exactly at 8:45, and we are very serious about it. So bye-bye. Have yourself a wonderful break, and see you at 2. Mkuje tu sharp tuanze class. Bye, guys.